Section 2.1 deals with linear functions. We will be focusing on how to graph equations of lines as well as write them in a variety of different formats. This first slide is just a nice reference sheet for you that has a few of those different types of formats on the right side, and then it also has a little graph of a line there. Two of the key terms that are utilized on that graph on the left side are rise and run. And when we're talking about rise and run, we're talking about the slope of a line. Way back in the day, when you first were introduced to slope, that is probably how you heard it expressed, that slope is rise over run. So as we look at calculating slope graphically between 2 points, what we can do is just utilize that concept of rise over run. So in this first example, I'm at the point 1, 0. If I want to calculate the slope of that line, again, I can just count, all right? So if I count up, that would be dealing with the rise. So in this case, my rise is 2 units up, and I'm counting 1 unit over. So that would be my run of 1. So the slope would be that rise, 2, over the run, 1. So my slope is 2. We could also, if we want, start at the other point first. So if I started here, now I'm moving down 2 units. So in this case, my rise would be -2. And to the left 1, the run would be -1. So in this case, we would do -2 over -1, which also gives us a slope of 2. All right. With the next example, if I start at -3, 0, I would be moving down 1, 2 units. So my rise would be -2. And then my run would be 1, 2, 3, 4 units. All right, because I'm moving to the right, that will be positive. So here we would have a slope of -2 over 4, which would reduce to -1/2. All right. In the next slide, these next two actually are usually what causes the most confusion. All right, if we look at this first one, if I start at this point right here, I do not have a rise. I'm not going up or down at all. So in this case, my rise would be 0, and my run would be 1, 2, 3, 4 units, although that's somewhat irrelevant. Here we're 0 over 4. All right, if I go 0 for 4 when I'm playing basketball, I'm shooting 0%. So my slope of that line is 0. And the slope of a horizontal line will always be 0. The next example, if I start at the point -2, 4, all right, my rise would be, we're going down 1, 2, 3, 4, 5, 6, 7 units. So that would be -7. And then the run, we're not moving horizontally at all. So that would be -7 over 0. All right, if I use that basketball analogy again, I can't make 7 shots when I don't shoot any. All right, that is not possible. So we state that our slope in this case is undefined. All right, the slope of a vertical line will always be undefined. So this is how we can calculate slope graphically. When we look at how to calculate slope algebraically, we can backtrack to this first slide and utilize this formula right here. All right. So as we look at that, to find the slope between two sets of points, you'll notice that formula said to subtract the y coordinates. So in this case, we can do this one of two ways. All right, I can go 8 minus 5. So if I go 8 minus 5, I have to start in the same place with the x coordinates. So that would be -2 minus 2. And in this case, this would become 3 over -4, or -3/4. So we would leave the negative in the denominator. We could also, if we want, work this the other way. All right. So the order in which you do it doesn't really matter as long as you're consistent. So instead of doing 8 minus 5 in the numerator, I can go 5 minus 8. That's fine. But if I do 5 minus 8, then I have to do 2 minus the -2. In this case, I'll get -3 over +4 as well. All right, go ahead and try to do letters B, C, and D on your own. You can pause the presentation right here. Okay, and this is what you should obtain. All right, so that gives you a representation of the different cases that you could have when you calculate slope algebraically. Make sure you always reduce fractions fully when you calculate slope. All right, if we look at our next slide, we're trying to find additional points that would exist on this line. You'll see some of these on your homework assignment, and just creating a quick sketch of these would be helpful. So if I start at the point -4, -3, all right, I know I have a slope of 2/3. So what I can do is just utilize that concept of rise over run again. So I can go up 1, 2 units, and to the right 1, 2, 3 units. So an additional point that would be on that line would be -1, -1. Another one, up 2 again, to the right 1, 2, 3. So that point would be 2, 1. All right. The next one, you can see we have the point 2, 1. All right, and then it says that the slope of our line is 0. Well, we just looked in the last slide, we saw that the slope of a horizontal line is 0. So any point that exists on this line would satisfy. All right, so I could use the point maybe 3, 1. And then if I wanted to get crazy, maybe I would include -4, 1. It doesn't matter which one you pick. Okay? Here you can see this first line. It is in slope-intercept form, which is one of the more common ways that we will express an equation of a line. That is right here, y equals mx plus b. So you have definitely seen this format before. When we're graphing a line in slope-intercept form, we always start at the y-intercept. So in this case, that's our value of b. This point would be 0, 3. And then we know that our slope in this case is 2, or 2 over 1. So we can go up 1, 2 units, to the right 1 unit. We could also move down 1, 2 units, and to the left 1 unit, all right? And that would give us our line. Usually we want to have at least 2, sometimes 3 or more points to graph a line. For the next example, the y equals -4. All right, this is an example here where our graph, that format is a little bit different than what we started with. There's no x involved in here. So what this means for us is we will go down 4 units. All right, that is where our y-intercept will occur. We go to where y equals -4. In this case, our graph has a slope of 0. When we have a y equals equation, this will be a horizontal line. When it's y equals and there is no x involved, it will be horizontal. So we go to where y equals -4, and then we just construct a horizontal line. All right, that is a line that has a slope of 0. The very unique case is when there is no y involved, and that's that last example, x equals 3. Here we would go to where x equals 3. All right, and whenever we have an x equals equation and there is no y, this means we will have a vertical line. All right, so the slope of a vertical line we know is undefined. And we'll just graph that in there, okay? Try to make it a little bit better of a line there. But we'll have a vertical line where x equals 3. Okay? Moving on to the final slide that we'll look at in this portion. Another way that we can express the equation of a line is in standard form, all right, which we saw here. Standard form is ax plus by equals c. And that's how it is expressed in this example right here. One way that we can graph a line in standard form, you could convert it into slope-intercept form by solving for y. Another way is to utilize x and y intercepts. All right, to find an x-intercept, you'll plug in 0 for y, solve for x. So if I wanted to find my x-intercept in this particular example, what I would do is plug in 0 for y. This will give me 2x equals 8, or x equals 4. So that would mean that my x-intercept is 4, 0. I can plot that point. All right. I could do the same thing for y. However, when a line's written in standard form, an easier way to do it is just cover up the value that you're plugging in 0 for. So for example, like with this x-intercept, what I could have done, I wanted to cover up or plug in 0 for y. I could have just covered this up, and then I'd have 2x equals 8, and that gives me x equals 4. To find the y-intercept, I'm going to plug in 0 for x. So I can cover this up, and this will give me -4y equals 8, or y equals -2. So my y-intercept would be 0, -2. Okay. So I'm at 0, -2. Connect those two dots, that will give me a graph of the line. All right. So whenever we're calculating an x-intercept, we'll plug in 0 for y and solve for x, and then the y-intercept, plug in 0 for x, solve for y. But when it's in standard form, you can use that cover-up method if you like. All right. One other thing that you may be asked as you work your way through a line that is written in standard form is to find the slope and the y-intercept. And there is a shortcut for that, and that is written down in that bottom box here. All right. To calculate the slope, you can take this value, the value of a, take the opposite of that, and then divide it by b. So in this particular problem, our value of a is 2. So we could say the opposite of that would be -2. And then the value of b, you can see, is -4. So -2 over -4 would give us a slope of 1/2. To find the y-intercept, we can look at the value of c and b. Okay, so in this case, our y-intercept we label with the lowercase b. The value of c in this case is 8. The value of b is -4. So 8 divided by -4 is -2. So our y-intercept would be the point 0, -2, which you can see is confirmed by what we obtained on the graph. And if you look at our slope, we said our slope was 1 over 2. Well, we can check that by going rise of 1 and run of 2. All right, so that checks out. Please click on to or head to the next presentation for the 2.1 flip.